Hi, Eric Lanask here in the TMC Newsroom. I'm chatting today with Rob Clyde. Rob is the CEO of Adaptive Computing. Rob, thanks for joining me.
Thanks, Eric. It's a pleasure to be here.
So, maybe start off for some of our viewers who aren't familiar with adaptive computing. Give me sort of the 30,000-foot overview.
Sure. So adaptive computing has been around for over a decade. We're in that space that deals with the collision of high-performance computing, big data, and cloud. In many ways, big data is driving that. But we actually, you would know us because we run some of the largest compute centers in the world, including the largest in the United States at Oak Ridge National Labs.
So you mentioned that from your perspective, big data is really what's driving that intersection or that collision, I think was the word you used. Is that what most people see, or are they looking at it from a cloud perspective?
Well, when I first got into this space, I definitely thought cloud was what would drive it. And to a certain extent it is. IDC indicated, for example, that 25% of the HPC sites are doing cloud today, so many are, but 67% are doing big data. And the difference is big data is really about how do I accelerate insights that can change my company, make me more competitive, or literally in some cases change the world. Cloud's really cool too, but it's about the infrastructure and how I could do things better. Both are useful perspectives, but I think big data has more of the business aspect to it.
So what is it about big data and the analytics? Because it's certainly not the collection. That the data has been available for a long time. It's been our ability to analyze it and use that information.
Yeah, that is the real challenge. Most of the CIOs I've talked to have said, hey, we know how to collect the data. We know how to store the data. We're not quite sure what to do with the data. And we actually have the compute power to harness that big data, analyze it, run the simulations, and the other aspects so that we can predict likely outcomes and ensure that we can get the insights that we're after. But that last piece is tough to do in today's compute environment.
What is the big challenge? Is it a timing question?
Yeah, the big challenge is, it is very much a timing question. So if you think of traditional IT apps, they tend to be stood up. Think of email, think of CRM, think of these kind of things. You stand them up and they keep running forever. And it's all about that kind of continuous uptime. Very important. Now we move over to big data and we're starting to get many more types of workloads that run to completion. They have a start time, an end time. Then you tweak them and you might run them again. And they can be massive. And so they suck up way more resources. So they're data intensive, they're often compute intensive, they're often complex. They don't just want a slice of a server or a virtual, or what we would often call a virtual machine. They want the whole server, many servers, maybe 30-40% of a data center in order to actually run. And how do you schedule and optimize all that so that they don't just collide and cause a big log jam?
So what are the elements that go into that kind of a scheduling or prioritization process?
So what you really have to be able to do is be able to see it both through time and space. Most organizations without having this are basically doing it by who do you know in IT that can actually get something to run right now. And of course they're going to collide. What you really need is the ability to look out into the future, know that these various workloads and workflows actually need certain resources, when you should run them, not just where you should run them, but when you should run them. You need to be able to be close to the data. Big data is stubborn. You can't move it around easily. Maybe you can move a few gigabytes around. A terabyte gets tough to move quickly around. Imagine, as we have many sites with petabytes that you're trying to move around, you can't move it around. You have the licensing issues, which applications are licensed where, how fast are the various I/O paths, where are the CPUs located, where are the free resources, what type of SLAs do you have to meet? Lots of things that have to go into that whole process.
So there are really a tremendous number of systems and informational resources that a scheduling process has to be connected to.
That's right, and it's got to be aware of those various pieces. If you think about it, it's a tremendous math problem that you're trying to solve and to optimize for as you look out in time and space.
What about power?
So power is something that's really getting interesting. We actually have some customers that can't get much more power. Their data center is so big for the community that they're in that they're being told, hey, you've about tapped us out. We have other customers in locations where when they exceed certain power thresholds, they have to pay a massive premium. And so recently we've added the ability so that we can actually idle or turn off resources, CPUs, et cetera, that aren't being used. I think this whole area of green computing is going to be very important as we head into the future.
Does geographic location start to play more and more of a role too as power and energy consumption continue to increase in terms of importance?
It does. Obviously, if your compute center is located in a smaller community, then you could tap out the power more quickly. It also plays a consideration, for example, as to what part of the world you live in, as to whether or not there are regulations or caps that might be put on your power. We see a lot of that from our European customers, for example, very concerned about staying under certain power thresholds.
Do those power thresholds and just the availability of power and resources, how much does that play into how SLAs might be changing?
Yeah, so as I look ahead to the future, today most SLAs are around I need certain workloads to actually complete by a certain time, and you've got to manage that whole workflow process to actually make that occur. Well, as we move forward, we're likely to actually see some SLAs that are written around stay within a certain power envelope, and that may actually be more important than the time to complete.
And are those variables, all of those variables that we've talked about, things that you're able to take into consideration with your scheduling?
Yeah, so adaptive computing, that's really what we do. And if you think about big data in that collision, we call big data plus workflow, it's a term we've coined that we call big workflow. Because it's got to take into consideration that scheduling, that optimization, and the tying together of the various pieces. Maybe there's a simulation, maybe there's something running in Hadoop, maybe there's some pieces that are running on our own homegrown data structure. We've got to be able to tie all those various streams together and actually come out with the result.
Are you seeing verticalization in terms of who needs this kind of scheduling, this kind of resource allocation, or is it more of a business size-based function?
Yeah, it's probably more based on the type of problem, and so naturally that lends towards a verticalization. So oil and gas, for example, with the seismic data and the sensors that they have, think of financial and analyzing, for example, trading as to what's happening on the stock market, or risk profiles that need to have intense computation that might go with them. In addition, of course, government, huge need for this kind of thing. Any type of research, so think of medical research, how do we cure cancer? So medical can be big, insurance can be big. But having said all of that, it really just depends on what the needs are. So as I look at big workflow, the use cases are, is it data intensive? Is there a lot of data? Is it compute intensive? And then finally, is there a bit of complexity that's going with managing those workflows? And if you have any of those ingredients, then I think it's ideal for our type of software.
Are there any particular use cases or particular customers that you can talk about that you find that you've seen that are particularly interesting in terms of what they've been able to and what they need to accomplish?
Yeah, one of the ones that's most interesting is a company called Digital Globe that processes satellite imagery. They have several satellites, and they have customers that actually have them do custom analysis in order to process that satellite imagery. It's really, really cool stuff. And so while they're doing all of this for various needs, such as planning for the future or being able to check for parking lot density or any number of very interesting things, they also have many customers that are first responders. So think of, for example, Hurricane Sandy or the typhoon in the Philippines. They have typically a 90-minute SLA where they have to get answers to those first responders on the ground about what is going on based on the analysis from the satellite imagery. Imagine the challenge of being able to preempt or being able to ensure that those workflows actually will go through the system in 90 minutes when those kind of things occur. And you've got multiple customers that also have important things that still have to keep happening during that window. That's the kind of thing that they can do with Moab, and actually, that's the name of our software product at Adaptive Computing, and actually make sure that can occur. Very exciting, fast-moving company that was able to do that with big workflow.
So they've got a 90-minute window with which to run these analyses and create a set of actionable data. Do you see those requirements, not for them or for other clients or business in general, requirements shrinking to where you've got almost real-time analysis capabilities that need to happen?
Yeah, I mean, they would definitely like to get it down further. I mean, as you know, Digital Globe has come to me and said, Rob, we've got a challenge we want to help you achieve. 90 minutes is great, but 90 minutes does mean that sometimes the first responders aren't successful. And that can literally mean an impact on people's lives. And so the idea is, let's see what we can do to even get that time down further. And everywhere you look, you see that. We absolutely have workflows that have to run in seconds and manage those. Sometimes it's not uncommon to have tens of thousands, up to a million of these types of tasks that are running simultaneously, many of which finish just like that. And you've got to be able to tie that together and actually show what the results are.
Are scheduling and workflow management requirements for those scenarios where you have hundreds or thousands or hundreds of thousands or more smaller analyses that need to be run different than some of the very large analyses?
They are indeed, and in those cases, if you were to just do the full overhead of scheduling it, that could exceed the length of the time that the actual processing was occurring. And so there are things that you can do to minimize that overhead in those cases, and we do have some very innovative things that we've done along those lines. So there are some subtle differences. As I said, the real trick with this is complex. The devil is, in fact, in the details when you're running these types of environments, and you run into the challenges that are going to occur.
So what do you see in the future? What's sort of the next opportunity for big data and analytics and for adaptive computing?
Well, big data is really coming into the mainstream, and I often like to say, we've done a lot of really big data. So this Digital Globe example I just gave, they generate 8 petabytes a year of new data. I mean, that's big data. But we have other customers that may only have a few terabytes, so it can be quite a range that's occurring there. But what we see occurring is that in many ways we are at the front end of the evolution of how we can accelerate insights using big data, which in many ways means big workflow is going to become mainstream. Using many of the techniques that were developed in technical computing and high performance computing, regular organizations and data centers can now be able to get those same kinds of game-changing, even world-changing types of insights out of their big data.
Excellent. Rob, thank you so much for joining us. With Adaptive Computing, I'm Eric Lenaskin, the TMC Newsroom.